All right, so my name is Mike. I will be going through this RHINO lathe today. So it's BobCAM for RHINO. V2 is the one I'm using, but the steps, if you're using V1, should be pretty much the same. There shouldn't be really any difference. I don't think they really changed much with lathe since then. So I'm just going to go right here to this top view. This is pretty much where I'm going to be for most of this. Now, I am not great with RHINO, so I actually drew this part out in our standalone software. It's just a part I use for a bunch of stuff. But I actually drew this out in our standalone and imported it as just a DXF. So I had it all lined up inside of BobCAD in our standalone version, and then I just imported it into here. So I'm doing everything from the top plane. The only thing we really need to pay attention to is when we set up the job, we need to make sure we have our Z and X right here and not our X and Y, which the turning system should do that automatically for us. So I'm going to go up to BobCAM, and then I'm going to go ahead and load the help right here. So this should load the online help. It may take a minute with the way my computer's been acting. Hey, that's not that bad. Okay, I can deal with that. So I just want to pull this up, and I'll just make this big. I don't need full screen. But every time you launch the help system in any version of BobCAM, but in BobCAM for RHINO here, it'll always take you to this introduction page. And what you can do is right here on this introduction page, we're going to go down to using CAM. Now, right here under Getting Started Machining, we have this Read Me First CAM Quick Guide. And I'm just going to open that up. Now, when we open this up, what we see is the generic kind of general process for machining inside of BobCAM. So there's 10 steps to it. They're all generic enough that this works for mill, this works for lathe, this works for wire EDM, mill turn, pretty much any kind of module for machining that we have. So the general process starts with start a new CAM job. And when we start a new CAM job, all we're doing here is defining what type of job we're doing. Is this a milling job, a turning job, a mill turn job, what have you? So that's where we're going to start. And I'm just going to slide this over one screen. And then right here, I can right click on CAM defaults, and we're going to go to new job. Now, the reason I like to pull this little cheat sheet up is everyone always seems to forget, at least at the beginning, the first couple of times, how do you start the whole thing? Well, first things first, if you don't see BobCAM, if you don't even see it over here, you can just type in the command BobCAM right there and say show BobCAM RHINO. That will launch your BobCAM inside of here. And that's actually probably what took a minute for my system to load. When I opened up this part, if the part has toolpath on it already, which this one did, it will automatically pull up all that toolpath. So it does take the initial load a little bit longer to load if it's bringing it apart, because it's got to load RHINO and it has to load the plugin, so it's kind of doubled up. So again, the main reason I show this is because if you forget this step, if you forget how to start the job, or you forget how to do the stock wizard, or any of these things that you see in blue here, you can actually click on it and you'll get a little refresh on how you can, do that thing. Now, it doesn't work as nice for when you get down to step like 4, where you're looking at CAM features. But it is still there. I mean, this is going to take you into this page where you could see Lathe Features, and that's where we go. And you got all your different features down here. So the help system has examples for just about everything. So step 1, we're going to start our new CAM job. And that means we're going to right click on CAM defaults and say new job. From here, we just choose the module we want to use, or whatever you have in your license. You might not have wire EDM, so you're never going to pick that. You're never going to be allowed to. But I'm going to go to turning right here, and I'm just going to use the BC3X mill. Most of us are able to use the BC3X mill, or sorry, BC2X lathe. Normally with milling, it's the BC3X mill, but for the lathe, it's the BC2X lathe. Pretty much everyone can use the BC2X lathe. The important thing is that you have the right post processor. This is just a very generic lathe, And so you'll just use your BC2X lathe for most things. Why are you up still? You need to go. Hold on one second, John. This shouldn't be here. Something's telling it to be here. There it was. Okay, that was the one. So we're going to go turning. We're going to use the BC2X lathe. Again, BC2X lathe is fine for just about everyone. I can't even think of a time I've had to change what type of lathe it is because all lathes for us are just 2-axis. And so, yeah, we just have to make sure we have the right post processor. Make sure everything's all set up. If you don't have anything as of now, you got to get in touch with the posting department and have them build that post. Or look online. I'll show you that website here at the end. So from here, if we look at our little cheat sheet once again, the next step is select a workpiece if necessary. Now that if necessary is important for us because you can only select a workpiece if it's a solid model. I didn't bring in a solid model for this turn part, but I could go and revolve it and make it a solid, but I really don't need it. We just need the wireframe for turning. So we're going to get into the stock wizard and machine setup on this. So I'm just going to say stock wizard. For the geometry, we're not going to pick a workpiece. We don't have a workpiece to select. So I'm just going to hit the next arrow right here to go into the actual stock wizard. Now, the first thing I like to pay attention to is that showing up in the correct coordinate system compared to all these ones? If you look, you don't really have to compare it to all of them, but we want to make sure that this is running down along what would normally be our x-axis for our top plane. But you have a choice. Depending on how your geometry is situated, you could say to use right now we're using the world right coordinate. We could say use the world front coordinate or the world top coordinate. So it's whatever you want to use. I'm going to go with the world right because that sets my z-axis here down the center of the part and my x-axis here along the part. So I'll go with that. Now I'm going to bring it back to the top view here. So for my stock diameter, I'm going to go with 6 inches. And for the internal diameter, if there was a hole already in your stock, you would want to define that hole. And you can see if I put this at, say, a 1/2 inch, there's now, let's go a bit bigger. Is that 3/4 of an inch? This will help me anyway because I need to know what size that is. Looks like it's a 1-inch diameter hole down the center. So you'll see a 1-inch diameter hole, if I go to my perspective view, has a hole down it. So that would be if you're starting with a piece of stock that has a hole in it. I only really did that because I forgot what diameter that hole was supposed to be. So it's a 1/2 inch radius of 1-inch diameter. That works for us. So zero that guy back out. And then for the length of the stock, you're just gonna put out however much you need. So if I say the length is 8 inches, that'll work. Now you could go a little bit more than that as well. You know, something like 9 inches will give me that little bit extra so that when I do my cutoff, I'll actually see it cut off and I'll see the kind of the rest of the material. So it'd be whatever's left in the chuck when it falls off. And then the origin right here. So right now the origin's at this center point, but if we want to do any bit of facing, we need to add a little material to face off. And what happens is when you add this stock origin, so say I go 100,000, so just 0.1, what it does is it just takes the whole stock and moves it 100 thousandths forward. So there it is. So it's just a shift on the part. But this will now give us 100 thousandths worth of material that we can face off. So after we have the stock defined, we're going to go ahead and hit the forward option. And right here we have our coordinate system set up. So it's still the same world right. We have our face geometry or our face clearance. So it's 1 inch in front of the part is our clearance plane for anything off the face. 1 inch around the OD for anything on the OD or on the diameter. And then it's just 50 thousandths for the ID work. We're not going to do any ID work. We're pretty much just going to drill a hole through this. But it's going to be 50 thou is where it's kind of, if we were to use a boring bar, that's where it's going to return to for clearances, which can cause problems, but there's other places to fix that. So notice there's no more next buttons, so we're just going to go ahead and hit OK. And then I'm just going to right-click on stock here and just say blank on blank, just to visually hide it. I don't need to see it anymore. And now if we go look at our cheat sheet, we have step number 3, which is select the stock material for the job. So this doesn't really affect turning the same way it does milling. With the materials, with turning, we don't really use the materials as a feeds and speeds calculator. So the only thing that's going to calculate feeds and speeds when we're turning is going to be any drills that we do. Anything that's something that could be used on a mill. So your drills, your center drills, all those things, those will calculate feeds and speeds based on what material you have chosen under this stock right here. Other than that, for turning, it's really not that big of a deal to set up the material. So it's totally up to you. Now, the other thing is in step 4 here, they go right into making toolpaths, and you absolutely could. But it does make life a little bit easier if we know what tools we're planning on using. Go and set up the tools before you start the job. So I'm not going to set up every tool, but I'm at least going to set up the tool I'm going to use for roughing and probably finishing and the grooves. So which is most of the tools. We'll just do it. So you right click here on turning tools, and we have a tool library and a tool crib. The difference between the two is the tool library. The easiest way to think about this is it's that shelf or drawer somewhere in your shop that has all the tools that you own. These are all the tools that are available to you. The tool crib is those tools being taken out of that drawer or off that shelf and being loaded into the machine. So I want to go to the tool crib because I want to then add tools from the library to the crib. All right. So we're just going to go right here to our rough and say add from tool library. And I'm just going to go with a pretty standard CNMG right there. Top one should be fine, and hit OK. We can use some pretty basic tools on this one. So for our finish, we're going to add from the tool library. This is going to just be a VNMG, and I'll hit OK. Now, I want to then go to my grooving tool, and I want to add from the tool library, and I'm going to go ahead and pick this one right here. Let's take a look at this one. So if I open up and I look at the tool on here, this is an 1/8 inch wide OD groove, and I specifically put long, meaning that the holder is a little longer right there. And all I did to make that was I made a new tool. And then when I was defining this groove, I went down here and said, let's edit that tool holder. And you can see right there, A is the length of stick out on that groove. So I can go in and say this is 1 inch, and it'll create it and extend it a little bit more. If I went 3 inches, like that. So that would give me another tool, which we kind of have that tool already. That's going to be our cutoff tool. So I don't actually need this one. I'm just going to trash it real quick. Yes. And I'm going to pick my 1/8 inch wide. So it's an 1/8 inch width for the tool. The tool length, so it's a 1/4 inch tall, kind of the length of the insert. The side angle is just 2 degrees, and there's no tip angle. Our reference point's off the left corner there, and that's the holder we're using. If I edit this one, you'll see, yeah, it's 1 inch. So that's just adjusted. I actually think I did this part in the getting started videos for this thing. So that's why this tool exists already. So I'll go ahead and just hit OK to add that one in. So we have, if we look at all tools right now, we have our rough, just a CNMG. Finish, just a VNMG, which we honestly probably don't need. We could probably just use the CNMG, but that's not going to hurt anything. And then we have our groove for doing those 2 grooves. So really the last couple tools we need is a center drill and a cutoff tool. So I'll just add those in. The drill I'm not going to add in. The system will automatically pick a drill. It's going to be a 1 inch diameter drill, but it's going to go 7 inches or so, something like that. So we'll just let it go. We'll see it. So for the center drill, I'm going to go ahead and choose let's go with a 3/4 inch 90-degree spot drill. Something pretty heavy. But I like using spot drills for my center drills, just so it gives me a nice clean angle. It's easier to calculate for a lot of things too. So I hit OK. There will be my center drill. And then, yeah, we'll go ahead and just add a 1 inch drill. Now, when we do this, I'm just going to sort by the diameter here and scroll down until I find me a 1 inch, or sort by the diameter again. And we probably only have Yep, one 1-inch drill. Now with this, I'm going to double click on it and you'll see the entire size of it. So you have a 1-inch diameter, 118 degree tip. The flute length on it is 6.375, but the overall length is 11 inches. So I want to go in and I want this to protrude out of the part a bit more because I do have a few more inches than that. So I'm going to say, I'll just do 9 inches. So we're holding on to 2 inches of it. 9 inches is sticking out, and 6.375 is what we have for our flute length. We'll see if that's good. I might get a couple little gouges telling me that my above my cutter, above my flutes is touching the part, but we'll find out when we run the simulation. Again, I'm not putting any tool holders on any of these tools, so it's no big deal. This is important though. So a minute ago, I was talking about our cheat sheet here that tells us to start the new CAM job and stock wizard and all that. But right here, step number 3 is set the stock material. The stock material is only used for feeds and speeds. So if you want BobCAD to figure out the feeds and speeds with turning, the only feeds and speeds we will calculate for are the center drills and drills, pretty much the same tools you can run on your mill. But if you do decide to let BobCAD do the feeds and speeds, you have to remember to set the tools to the correct material. Right now it's saying this 1-inch drill is high-speed steel, which it might be, but you also have the choice of doing insert or carbide cutters. So depending on how you're doing your feeds and speeds, you really do just want to make sure the tools have the right material set for them. If it's carbide, set it to carbide. If it's high-speed steel, set it to high-speed steel. So just going to go ahead and hit OK here. And there's that super long drill. And then finally, the last tool we're going to need is a cutoff. And I believe there's only one in here. The length on it is 3.25. So if we look at the holder here, we only got 1.625. So this should be 3.25. And that's what it should look like. So it's basically a groove tool, but we use it specifically for cutting off. And my part's 6 inches in diameter, so I had to make sure I have a few inches of that. Shank length we can make. Oh, that's the total length. Yeah, 3.25. All right, perfect. So we'll hit OK, and then hit OK, and there's that tool. So now we actually have a cutoff tool that can reach the center of the part. And that's it. So if we go up here to all tools, we have 6 tools. Our rough and finish for most of it, our groove for the grooves, center drill and drill for the drill and right down the middle, and a cutoff tool. So again, you do not have to do this. If you look at the steps, our little cheat sheet here, there's nothing in here that's telling you to set up all these tools at the beginning. But I found that if I don't have to think about the tools again, that's a great day for me. I know what tools to use when I'm roughing. I know what tools to use when I'm finishing. It all works out. So I do prefer to set up tools in the tool crib before I start machining. But I'll say that is not always the case. There's many times when I was playing around with this earlier before lunchtime, before this whole thing started, I didn't change anything. I just started building it and making up tools. So there's 2 ways to go about it. I think setting up your tool crib first does help with kind of organizing everything and making sure it's all good. So I'll go ahead and hit OK. And now I have my tool crib. From here, we have our stock done. We have our tools done. So now we are ready for step number 4. All right. So step number 4 is start making tool paths. All right. So we always go to the same spot to make a tool path. We're always going to right click on machine setup 1 here. So we right click on that. And the first thing we're going to do is remember we added 100 thousandths to the front face. So that's what we're going to take care of first. That 100 thousandths off the front face. So I'm going to go lathe end face. For the geometry, I'm not even going to pick any geometry. I'm just going to let BobCAD figure out where the geometry starts, and it should have a pretty good idea of it. So we'll go next. Now, because this is specifically a facing feature, we don't have to change our feature type. It knows it's working off the front face. Basically, it's only going to give us the settings for facing. So we can't change what face it is or anything like that. The rapid plane is the distance we're going to return to between each cut, so 200 thousandths. So as we make our first cut, we're going to go 200 thousandths, come in, make our second cut, 200 thousandths. The constraints for this one, it's you get from stock or from custom. I always go with from stock, especially on a facing pass. The only time I really change this option is when I'm doing grooves. And I'll show you that here in a few minutes. Now, the extension allows me to extend past the center point or start before. So I like to start, we'll give ourselves an extra 1/8 of an inch. So it should see the stock and start an 1/8 inch above it. And then at the end, we're going to go past the center by, we'll just say, a 1/16 of an inch or so. And that'll just get rid of any little tit that's left on there. So next, we have our machining strategy. Now, this is just a facing pass. So I don't really need a rough and a finish. If I don't want to, I could just run a roughing pass. Or it's 100 thousandths worth of material. So if you're cool taking that off, depending on what you're machining, you could also just do a basic finish pass. But I'm going to go with the rough pass. And you know what? I'll do a rough and a finish just because it's pretty simple. So we got our rough and our basic finish. Next. All right, for posting, this is all dependent on your post processor, whether you can output as separate moves or CAN cycles. Separate moves is going to be longhand code where everything's broken down. CAN cycles will be CAN cycles. So you just have to make sure to pick the right parameter based on your post. Some posts don't have all the CAN cycles in them. So I'm just going to run it with separate moves. And next. Right here for the rough, we have our CNMG. That is the tool that we chose while we were putting all those tools together. Down below that, we have the corner radius. So this is a 64th rad. I could change my decimals. All the decimals are used. They're the same as whatever you have for RHINO. So whatever settings you have for RHINO for decimal places, it's the same here. The nose radius, the inscribed circle diameter, this is a 1/2 inch insert. So a beefy little insert there. And then for the tool orientation, for OD stuff, it really doesn't, you really don't have to mess with this. And if you're doing ID stuff or back face stuff, back on the original feature page, that's usually what this thing handles. This feature type actually handles most of that for us. So we're not going to change anything. The tool that's chosen is the tool I want. You could change the orientation on how the tool sits and cuts, but like I said, I'm going to leave it in orientation 1. It's tool number 1, and we're using the offset register 1. Basically, the way I'm doing my tool numbering right now is the order that I use them in will be the number that they are. You know, the first tool is going to be tool number 1. Second tool used is going to be tool number 2. You can always change those at the end of the job, though. You can always go into your turning tools and verify your tool assignment to see what tools are actually being used. So I'm not going to do that right now, or we don't need to worry about that right now. You got your spindle direction of clockwise or counterclockwise. Your coolant type is flood, mist, air, oil, or you could turn it off. And then feeds and speeds. Now, like I said earlier, we do not calculate the feeds and speeds for your turning job. We give you the choice of using an RPM or constant surface speed. And you're just going to enter in the values you want to run with. So we'll go next. And give me 1 second. I need a drink. All right, now for the patterns. Now this is a facing pass, so we really won't use any of these patterns, but if you look at that picture there, it's not showing us a picture of a faced part, it's showing us a picture of a turned part. So this is actually patterns that you'll use more often when you're doing your actual roughing and turning, not your facing. But we can see we have a standard cut with a standard sort. That's how we probably picture most of our cuts happening. We're going to make a cut, we're going to come back to the beginning, we're going to make a cut, come back to the beginning, make a cut. Pretty straightforward. We also have the ability to do on the pattern here an offset. So we're chipping away at it a little bit more, basically just kind of like how you do it as a pocket on a milling machine. But with this, you're just going to take out a little bit and the tool just constantly follows the shape of the geometry. The problem is, and I see it right here in this picture, that first pass only takes a little nibble out of there. This second pass now has to take all of that material in one shot. So your machine, your tool might hate you while it's doing that little move there. And that's where I usually go with standard, because standard I can define my 50 thou, 25 thou, whatever I want between each pass. Offset looks like it'd just really be probably the second one most of the time that would have a problem, but that's a pretty aggressive cut. The last option for sorting is the zigzag option. So instead of going back to the beginning and cutting, basically, instead of doing a zig where you go in one direction, you'll do a zigzag where you go back and forth. So you got your forward cut here and then a back drag cut there. So you got to make sure you got the right tooling selected for this. You got to have, something more. When I do this one, I've only done it a couple of times, but when I've done it, I've actually used more of a grooving tool than a CNMG or something. So I'm going to go with standard and standard on there. For the compensation, I don't use G41 and G42 on a lathe usually. I like to let BobCAD handle all the compensation. And so up at the top, we have our system compensation. That's exactly what that means, that BobCAD is going to handle compensating this tool. Now you have three options for that. Off, which is basically a center line cut. You're just going to follow the geometry in the exact shape we made it. Usually when you're using off, you're going to be using some form of compensation, a G41 or a G42. That's totally up to you guys. Like I said, I don't really use them. A bit of it comes from the fact that it doesn't show properly in BobCAD. It needs that compensation applied to it already, but I'm going to leave that one off. The other one is called on without collision detection. So this means we are going to compensate for the tool, but we're not going to look to see if it's crashing into anything. Like that picture shows, the back of the holder and the back of the tool end up dragging across that section. And so the one I use, because I'm not lying about my tool, this is a pretty standard tool. It's a CNMG. As long as you're not trying to trick it into thinking you got some tool that you're not really using, the best option for me is always on with collision detection and tell it to use the tool holder. So it'll adjust the path so that the holder is clear on the part. And that's it. And that's the setting I'm going to turn on pretty much every time. So next right here, we have our parameters. This is where we see our depth of cut. So whatever you're comfortable with taking out in one pass, or whatever you're comfortable with the tool taking, that's what we're going to set up here. The allowance, this finish allowance here, this is the amount of material that's going to be left over for our finish tool to clean up. Right here, we have some overlapping options. So how do we make our cut? So the default is no overlap, and this is what you'll use. The default for facing is no overlap. But when we get into turning, what happens is on no overlap, you make your cut, you leave. You make your cut, you leave. So you can picture the finish that's going to be on here is going to be very steppy. There's going to be a lot of steps in it. All right, we're kind of a rougher finish, or a rougher finish for it. Now, to previous cut and custom distance, what those are doing is leading out to the previous cut, or custom distances is a certain distance that you can use to blend. So no overlap is leading out here. To previous cut on this same line is actually leading out all the way up here. This lead out that we're seeing here is for this line down here. So it's going to cut that line, feed up this, and then leave. And as you can see, that's going to leave a much smoother kind of finish on the part. And it doesn't add that much, it really doesn't add that much drastic time to it. It doesn't really matter for us on a facing pass, though. Now, right here, we have a chip break option. So if you're already know you're going to get some bad chips on the part, we can actually do a chip break which lets us break the chips at either a length of cut. So you could say a 1/4 inch. We could do a certain amount of time cutting before we lift the tool and kind of break the chip, or we can do it based on the length of the chip. And then the retract distance is just how high do you lift the tool to try and break that chip. So I'm just going to cancel out of there. I'm not even using that. Corner types, again, some of these options are just here that they don't really affect a facing toolpath specifically because a face is just going to be, a straight cut. So there isn't any corners on it. But if we look at the corner type options, because again, these all will work, these all apply to the next toolpath we're going to see, so it's not that big of a deal. With this, it's just how do we interpolate corners? Do we go with a radius and make an arc move, or do we go with a sharp? Regardless of what you choose, you're going to get the corner that's drawn. This is just how do you want your code to come out? Sharp or round. It just depends on the code. But that corner is not, if we use round, that corner is not going to get a radius applied to it. If it was, then it would ask us what radius we want to put on it. And there is some features like the cutoff that will allow me to put a radius or a chamfer on while I'm doing the cutoff. Right down here, again, one of these options I rarely would ever use with a face, but it's called trim to stock. Now, trim to stock is a good one if you're going to be turning a part that's maybe had some pre-turning done or maybe a casted part. What you'd want, though, is two models. One model that represents the final finished part and another model that represents that stock. So if you look in the picture, it's real faint here, but there's stock right in there. And if we don't trim to the stock, then the toolpath is going to cut a bunch of air. But because this part's a casting or whatever, it already has a lot of that material gone. So you could say trim to the stock size, and it'll only cut where it needs to cut. All right. So I'm just going to go ahead and hit next right here for the rapids. Now, the next few pages, the rapids, the leads, the advanced feeds, we're not going to make many changes at all. The approach that we have, I'm going to use the default rapid approach. And on the exit, I'm going to use the default rapid on the exit. Now, my goal with some of these pages, or with most of these pages, honestly, is to change as little as possible. A lot of the settings that are in here because they work. They work a lot of the time. So I'm going to go with the defaults on this. And if they don't work, I can always come back and change them. But there's a good chance they work. But as we're talking about it, you can see we could come from the OD clearance plane, the ID clearance plane, or the face clearance plane. You could also rapid to defined points. On the exit, you have a rapid on exit to the tool home, to the cycle start, or to a defined point. Now, you'll see these letters afterwards, the X-Z or Z-X or just ZX. And the difference in each one of these is X-Z means X is moving first and then Z is moving. Z-X means we're moving Z then X. And ZX is both of them at the same time. All right. Go into that home position, which is defined right here. Now, you may have to change the home position, but just so you know, the home position is actually stored when you build the tools. So if you ever need to change it or you want to change it for certain tools, you need to go to that specific tool in the library. And if you scroll down to the bottom, you'll be able to change the home position. Again, with something like this, though, I don't really need to change the rapids. I'm just going to go with the default rapid on exit. The only time I really concern myself with the rapids is when I'm doing ID parts. When I'm cutting something on the inside of a part and I got to reach some sort of boring bar in there and clean it out. Other than that, I try not to mess with it. So that's my goal here. I'm going to leave it on the defaults. Next. Right here for the leads, we got lead ins and lead outs. Just like the rapids page, I'm going to leave them right where they're at. I'm not going to make any changes. If these work the way they are, perfect. I've already added an 1/8 inch on the extension way back at the beginning. So this is just going to be kind of added on top of that. So no changes on the leads. Right here we have our advanced feed rate, so we can convert our rapids to feeds. And we could change our lead in and lead out feed rate percentages. Now this convert rapid to feed, what that does is it takes the G00s out of the code and replaces them with G01 feed moves so that you can feed instead of rapid. You're actually going to define your rapid, your feed rate essentially when you turn this on. This is to help with an issue called dogleg rapiding. And it's caused when your rapids, instead of being moved in a perfectly straight line from one position to the next, they kind of have a little curvature to them. So yeah, we're not going to change anything there. Just go next. For the basic finish, because I set my tool crib up, it automatically grabbed whatever tool was inside the finish category, which for me was my VNMG. And that's exactly what I wanted it to do. It's one of the major benefits of setting up the tool crib beforehand, is now BobCAD knows what tools you plan on using, and so it can pick them. Now, if we had more than one finish tool inside that category, it doesn't know which one we want to use specifically. So you would have to make sure to, you would have to go in and pick it. But picking tools is pretty straightforward. You go up to the tool crib right here, and if there was other tools in here, you'd pick it. You could even use roughing tools. It doesn't matter. You can use whatever you want. But we're going to go with that VNMG. The rest of the page is pretty much the same as the other tooling page, so we'll go next. For the patterns, you have two patterns for finishing. You could do a continuous pattern, and again, a lot of these are more for turning. That's why these pictures show this way. So continuous is going to go start from the beginning and just feed its way back. You could use the chip break options for breaking any chips. That way, hopefully, you don't build up that huge rat's nest right in here. But that's on the next page, so it doesn't matter now. The other options are doing an alternate cut. So you could say, I want to turn my faces vertically, and you're going to kind of back drag those, cleaning up the, what did we leave, 10 thousandths or so. You could also say, I just want to focus on turning the diameters, or you can do both. So you're going to turn all your diameters, and then you're going to come back and back drag those vertical faces. And that does get rid of a bit of the chip buildup that you have. Not bad, but I'm going to go with just continuous. This is a facing pass anyway. For the compensation, I'm going to say on with collision detection using the tool holder. And we'll go next again. Right here, there's not many parameters for a finish pass. If we were leaving material that we're going to come back and clean up later on, then we would leave this at, or we would add a value into here, 10 thousandths, 20 thousandths, whatever. But we're not. We're trying to finish it to size. So that's going to be a 0. For the chip break down below, again, you could do a chip break. You could change your corner type, or if you could, trim to stock. But we don't have any of that stuff. So next. Here's our rapids. Again, let's use the defaults. Our leads, going to use the defaults. And the advanced feeds, going to use the defaults. Now, be aware that this option right here, the compensation option on the patterns page, does make the toolpath take a little bit longer to calculate. But it is, for me, it's worth it because it adjusts the path to make sure everything can cut properly. So I'm just going to go ahead and hit compute. And this is taking a while just because my computer is not happy the last couple days, so I'm just dealing with that right now. So, all right, we're going to let this finish calculating here. Oh, Mark, you're back. Yeah, it says you popped offline here a minute ago. Not sure what's going on. Did we kick you off, or was it your internet? And there is our toolpath. It's just going to go in and make the cut. Do I have, give me 1 second. I want to look at some settings for BobCAM here. Move over a little bit. There we go. Did I get it? All right, good. I thought this had the new cam tree in it. What is going on? All right, give me 2 seconds. I want to go to, where is it? Settings right here, current settings. That's not the settings I wanted. These settings, I believe. User interface, office blue, okay, cam. All right, I want to turn on the, there's classic, that's what I've been looking at. I want to go to the extended cam tree here. And I want icons. I want it all to the right. So yeah, let me hit apply. And okay, that's what I want to see. Oh, you're on your phone. I got you. Cool. All right. So right here we have the, I just extended my cam tree so I could use these blank and unblank options. I don't remember when I would have turned that off, but apparently I did at some point. So yeah, you just want to, let us visualize it a little bit better, what's seen and what's hidden. So if I blank this out, there we go. We have our rough pass right there. So you got all those passes, a few of them, and then our basic finish right there. You'll see we're going past the center line by just a little bit there, and it's good. So now I'm just going to go ahead and shrink that one up. That's how I kind of know for myself that I'm done with it. And yeah. So now I'm going to right click on my machine setup one. And this time I'm going to go to Lathe Turning. Because what I want to do is I want to turn down all of this geometry. Now notice I'm going to pick everything. And I just have to pick the little fillet in the beginning there. That little fillet there and this edge right here. And look at the chain. You'll see we're starting here, going around. Now you'll notice I picked the grooves. We do pick the grooves in BobCAD because when I hit OK and I hit next, on this feature page here, we have this undercut section. Grooves are seen as undercuts for the system. So we can say, let's go ahead and remove primary undercuts. And what that does is it tells the system to ignore any turn grooves. If we were to say remove secondary undercuts, you'd be removing any face grooves that are on your part. If you have them both checked, you're removing all turn and all face grooves. Now, if you have angled grooves, there's no way to ignore those. The only way to really ignore some sort of angled groove would be to draw a line across it and then pick that line as part of the geometry. So it works for turn and face grooves, but if you have any angular grooves, yeah, you'll have to draw a line over that. So I'm just going to turn both those on. I don't have any face grooves, but it won't hurt anything. For the rapid plane, it's 200 thousandths for our return every time. We have our feature type. So this is actually one of the easiest ways to control the tools. So I'm doing an OD cut, so it's kind of aligning my tools as if I was cutting for an OD part. If I was to say ID, it's actually going to rotate and flip my tool around so it's facing the correct direction. We also have our front face options and our back face options. And you could choose with OD, I could say OD region 1 is kind of the, we'll say the right side closest to the face of the part. Region 2 would be working more close to the chuck of the machine. So you'd be coming in and machining your way out. Basically, it's the flip of your tool. So right here we have our constraints. Because this is a pass, this turning pass, that's basically going to be my material removal, my big material removal. I'm going to tell it to use the stock as the top of feature. So just recognize the stock and go and machine it away. The other thing I could do is add extensions onto here as well. So if I want to start a little bit before the beginning, kind of get the tool in position before, and maybe go past the end of the part a little bit. So I'll go, let's go distance. We'll just do an 1/8 inch. So that should just extend this to go past here, just a little 1/8 inch more. That's helpful for if you're doing, you're going to do a cutoff. My stock right now is 6 inches, so it really doesn't matter. I'm just going past it a little bit more. For the machining strategy, once again, we're going to go with a rough/finish. You also have options for a pattern repeat, which is basically the finish pass being offset and dropped in, so you're following the same shape every time. I'm going to go with rough and basic finish here. Next. Right here, again, you have separate moves or can cycles. That's really going to be dependent on the post-processor. Right here, we have our roughing. So again, I'm going to use my CNMG to rough it. No changes pretty much on that page unless I was changing feeds and speeds. That's got the tool. It's got the right orientation. You can look at the tool and the holder together right there. Looks good. So we'll go next. For the patterns, again, just like with that facing toolpath is essentially this roughing and basic finish toolpath anyway. In the old versions of the system, we didn't have just a specific face. The main reason why there is a specific facing toolpath is because it automatically recognizes the geometry. It will automatically go in and do that face cut. So it recognizes how much material is there, and then you just go cut it off. So it's the same options. You got your standard and offset for your pattern, and your standard and zigzag for your sort. So I'm going to go with standard. I'm going to say on with collision detection using the tool holder. Now that's a setting I turn on all the time. I don't usually do any saves on well, this is my work computer. I save stuff on my personal stuff. But if you know that this is an option you're going to use a lot of times, you can come in here and actually say save defaults. And you can say, I want to save it to the current template. I want to save it to an existing template, which overrides this setting on the system level, on the default level. So every time you do this, it'll have that. And you'll say you want to save it for your rough and your finish. For me, though, a kind of a shortcut so I don't have to change it on the next one is this button down here in the bottom left. It's the Apply to All Operations button. So Apply to All Operations is going to copy the settings from here to these settings down here. All right, so it just copies it over so I don't have to make that change twice at least. But after that, we'll hit next. We have our parameters. So depth of cut, again, whatever you're comfortable with. The allowance, you have two different allowances. Now, the rough allowance is used basically as a rough pass. I use this when I do the pattern repeats. I use a rough allowance. But for this one, I'm just going to go with a standard kind of normal allowance. Leave me 10 thousandths on every surface, and that's what my finish tool is going to clean up. Now, on the overlap, I like to use to previous cut when I'm doing these cuts here. Just because it does give me kind of a semi-finished part before the finished pass comes in. I'm not going to have a bunch of steps in there from the kind of initial roughing to it. On the chip break, I'm not going to do any chip break right now. Corner types, no changes. And then the bounds, we could say I want to trim to stock if we had a model that represented that. We don't have that model. So you can get that model. Excuse me, sorry, I just hit the microphone. You can get that model from the simulation, though. And actually use it. So I'm just going to hit next for now. For the rapids, again, we're just going to use the defaults. There's no point in changing it if we don't have to. Right here we have our leads, so we could go parallel or angle. Again, just going to use the defaults. If they cause a problem, I'll fix that problem, but they usually don't cause a problem, so no point in changing them. Advanced feed rates, no changes. And then there's our finish. Once again, we got our VNMG right there, 64th rad. What we planned on using for finishing anyway. And next again. For the patterns, I'm going to go with a continuous cut, but again, you could go and do that alternate cut where you do the face verticals separate from the turn diameters. System compensation set because I use that Apply to All Operations button there. The parameters, we have our finish allowance set to 0, so we're finishing it right to the wall, and our X allowance right to the floor. So it should be a nice finish here. Next. On the rapids page, we have our default rapid on the approach, default rapid on exit. We're going to use that. Leads, parallel, angle, both set to 100 thousandths. We're going to use that. Again, try not to make these changes. If you don't have to, you don't have to. You know, it makes it a few less things to worry about most of the time. And again, advanced feed rates, no changes. So I'll hit compute. And again, it will take a little bit to compute, but it shouldn't be too outrageous. And if your computer's not having a bad day like mine is, it'll actually compute faster because it's not having a bad time. So I'm supposed to be getting a new one soon. I just keep holding on to that. All right. So here is our rough pass. Just going to go in and rough all that geometry out of there. And then we have our basic finish. So just going to turn and cut. Now, a lot of guys get nervous when they see this right here. The toolpath is inside the geometry. All right. The reason it looks like that, and I can show you this, is because all the toolpath is based off of that point right there, the hypothetical corner on the tool. All right. It's what you're calculating when you're setting your tools up anyway. Excuse me. Oh, I didn't mean to hit compute. Sorry, guys. And so if I right click on this basic finish here and I say back plot, my tool is going to be up there. Let me just next my way into here. Next. So there's my tool. I'm going to turn it shaded. And you'll see as we touch, the hypothetical sharp corner is basically, actually, looking at this, it's this corner right here. So when we get up to that arc, the reason that it's like that is because that hypothetical corner is down further. That's what we're calculating everything based on. So when you see a toolpath inside the geometry, it's not a bad thing. It just means that the edge of the tool is cutting along the geometry. All right. So yeah, there's the only other way to get it to run without doing this. This is that compensated tool. If you go in and you change this to, let me edit this right here. If I was to go down to the patterns on this one, I was just to turn this off and hit compute. The rough still has to compute, but the finish is now going to be pretty much instantaneous. So now as the tool runs, so I'll backplot that. There it is. When we get to right here, the tool isn't actually touching the part. It's not touching that wall. That's because normally you'd be coming in and then compensating it with a G41 or a G42. So I'm going to turn that system compensation back on, and I'll just recompute real quick. All right, and there we have it. So there we go. Looks good. All right, now we'll go ahead and just shrink that up. And then the next thing is these grooves. So for the grooves, I'm just going to right-click and say Lathe Groove. We'll select our geometry. And I'm just going to drag a box over this stuff. Whoops, didn't mean to grab that one. Just going to drag a box over those two areas. And then I'll just fill in the kind of gaps that I missed. There we go. And we'll look at our two chains. So we'll see both of them right there. Right there. You can do both your grooves at the same time, or you can make them separate features if you wanted to for whatever reason. If you were going to make them separate features, though, the way to do it would be to just program one and then copy and paste the toolpath for the other. But you don't have to. You can do both your grooves at the same time nowadays. So I'll hit OK. And then go next. Right here's our rapid plane once again. So that's pretty much the height at which we're going to return to when we connect these two grooves. They are OD grooves. We're doing region 1. Region 2 would be kind of flipped the other way. So your tool would be flipped 180. But we're going to go region 1. If you did have angled grooves, you can actually set the angle of the groove, and then you could set up your tool to match that angle when you go in and cut it. But for the constraints, so for just about everything, for your normal turning, your facing, pretty much everything, you're going to go from the stock. But for the groove, we want to go from geometry. And what that's doing is it's looking at the height of the geometry we picked, and that's where it's starting all the toolpath. If this was up any higher, it would, if we had this extended up, it would actually start the groove higher. So it's actually looking at the geometry. And so I'll just go next. I don't need an extension on this one. We'll do a groove rough / finish, which is going to go in and rough the groove out, and then add just a little finish pass to it, just something to clean up that groove. Next, again, we have our posting, separate moves or can cycles, all dependent on your post. For the grooving tool, if I show my holder, that should be it. It doesn't look like it's as long as the one I made, is it? Oh, yeah, look, it picked two different tools. We got tool 7 and tool 3. Not sure why tool 7's in here, but we're going to go in and make sure to pick tool 3, because that's going to have that longer stick out on that groove part of it. Not sure why it grabbed the other tool. It grabbed the same tool, which is weird, but next. Right here for the patterns, we're just going to go with a standard cut, but you have other options. If you have a custom-made grooving tool that is made to cut a specific shaped groove, you can use single pass. And that's just going to press into the groove, come back out, and that's it. Your standard cut is going to plunge in. Just plunge in and make the cut. And with that, you can do a standard cut. So you're going to go 1, 2, 3, 4, 5. You can do a center out. So you're going to start in the middle of the groove and then work your way out from the center there. You can do a center out alternate. So you're going to do 1. And then in this case, if you look at the picture, we go to the left. Then we go, then we go back to the right, back to the left, and back to the right. And then finally we have skip. You're going to cut one, skip a section, cut it, skip a section, cut it, and then go back and clean up the areas you skipped. Now the other option for the pattern is a zigzag. And a zigzag is going to go in and zigzag the groove. It's going to cut its way down. I'm not going to run that. For the collision checking, or basically the compensation on this, I can turn on use the tool holder. And this is a good one for if I'd accidentally, not paid attention to the tool length that was sticking out on there, and I picked that tool that was too short to get to the bottom. This option would have actually shortened the tool path basically to the level that tool can cut. It wouldn't go to the bottom. It wouldn't force it to gouge. It would stop where, it would stop as far as it could possibly reach. All right, so we'll use the tool holder. That all looks good. We'll go next. Right here, again, we have our step over. What are we comfortable with it taken out? I'll say 60 thou, about a 50% step over there. For our allowance, we're going to leave 10 thousandths for that finish pass to clean up. And right here, if you're doing some deeper grooves, you could tell it to take out multiple depths. You could do a depth of cut at, say, groove it at 100 thousandths, and then the next 100 thousandths, and the next 100 thousandths, and work your way down. For processing, we can go by area or by level. And so you can see by area is probably the most consistent, probably the way I usually would do it. You're going to cut, finish an area, and then move on to another one. By level is going to take everything down at the same level. So you'll do step 3, then you'll come back, do 4, and then 5. But I'm going to go by area. For the sorting, we have one way or zigzag. So if you're doing multiple steps or you're doing anything like that, you could say, make a cut this way, then drop down, make it back, and just kind of go back and forth. You're still plunging the same way. But again, that's usually going to be used with the multiple depths option. Right here we have pecking, and so pecking is going to let us peck our first amount. So what's our first peck going to be taking? What's our increment after that we peck? And what's our clearance? So what do we retract every time we do that peck? And then right here we have our trim to stock option. So again, this would just trim it so that it recognizes where the material is. But our constraints option will actually pretty much do the same thing for us, so not a big deal. Next, we have our rapids. Again, going to use the defaults. Not going to make any changes to this one. For the leads, we only have one option. It's parallel leads, and they're set to 100 thousandths. So unless 100 thousandths isn't enough, you really don't have to change this. And then advanced feeds. For the groove, I'm going to use the same grooving tool. So tool number 7 here is not the right one. It's tool number 3. And you'll see when we pick tool number 3 and I hit OK, if we go back into the tool crib, tool number 7 disappears because that wasn't a tool that was chosen by us. It was a tool that was chosen by the system. I don't know why, especially since the tool we selected is the only one in the tool crib with that name. And we edited the holder. So I don't know where it got that other tool and holder from. It's a weird one, but we'll run it this way. Next, we have our patterns. So we got forced down cutting. So from both sides of the groove, we're going to come in and cut to the middle and just kind of overlap. And you could actually put an overlap amount between them. So I could say I want to overlap by a 1/16 of an inch in the center there. We also have basic finishing, and basic finishing is just going to plunge in. You're just taking off the whatever's left over, 10,000. So it's going to feed in, cut around, and back out. I'm going to go with just a basic finish. We do have our compensation again, only this time it's just off or on with collision detection. There's no on without collision detection. So I'm going to say on with collision detection using the tool holder. For the parameters, I'm just finishing everything. So we're going to leave that stuff at 0. The corner types, we're going to go sharp or round. Again, it does not change how the corner is going to come out. It changes, it's the interpolation on the corner. All right. Now we'll go with round. Next, we have our rapid. So the default rapid on the approach and the exit. Leads, going to go with the defaults. And advanced feeds. When we're all done, I'm going to go ahead and hit finish on this one, just because. I'm going to say finish. And then that way I can go up and just say file save. So I'm just going to say save. I believe I have it saved. Yes, it's in there. Cool. And now I can go and compute that toolpath. Just instead of hitting compute, I hit finish just so I could save it between them, just in case something happens during some sort of calculation. And let that run. All right. So there it is. We're going to go ahead and hide that. And then here we see there's our groove rough. There's our connecting right there. And our groove finish right in there. So we're coming in from this side, going there, coming in from this side, going there. Now you'll see this adjustment here. Remember, that's because we're using that hypothetical tip. The hypothetical point on this, or the point on this, is to the left of the cutter. So the left side of the cutter is what's going in here, and the right side is what's actually cutting the wall. So we'll shrink that up. We're done with our groove. All right, now we'll do our drill. So we're just going to right-click here, do our lathe hole, and we'll select our geometry. The geometry for this is really just the end point. So we're going to just pick that end point and hit OK for however deep we want to go. That's what we're defining, is the total depth. The diameter, this is 1 inch. I already set this drill up, so it should pick it for me, or if not, we can always pick it. Now you have a choice of doing a through hole or a blind hole. The difference between the difference between the two is a through hole adds 50 thousandths onto the total depth. A blind hole does not. We do still calculate the tip angle to make sure that the full diameter hole is 7.5 inches, but we don't add any extra on when you do a blind hole. So I'll just do a through hole, no big deal. For the strategy, I'm going to choose this lathe hole option, and that will give me a lathe center drill and a lathe drill. That's it. For the posting, again, separate moves or CAN cycles. I would say most post processors have the CAN cycles for drilling, but it's just dependent on what's been done to that post, really. Next, we have our center drill. So it's my 3/4 inch 90-degree spot, the one I set up earlier. Next, right here, I could define either the depth that I want to center drill to, or the center diameter I want when this drill is done. So I could go in here and say, I want my center diameter to be a 1/2 inch wide. And that means that with this 90-degree tool, we're going to go 1/4 inch deep. I could choose to do it as a single depth, just the full 1/4 inch in one shot, or I can peck or even fast peck my way in. Right here for the rapids, we got the default rapid on the approach and the exit. For the lathe drill, we have our 1 inch drill, which this looks like the tool I set up, but yeah, this should be it. Let me go to the tool crib. Let's look. Is this? It's the same exact tool. I'm going to go ahead and choose tool number 5. I don't know why it's making up these extra tools. I'll have to get with the dev team and look at it. But yeah, from here, this is one of the only features we're doing that BobCAM is going to calculate the feeds and speeds because of the material over here. So it's calculating those feeds and speeds. For the parameters, we're going to tell it to use the cutting conditions. So if we remember, our total depth was 7.5. There's that extra 50 thou. And then you can see the tip is 30 or 300 thousandths on this. So this extra distance between these two, that's the difference between the full diameter to the tip. It's a 118-degree tip. So there it is. And it will actually adjust. If you were to change this to like a 135, it's actually a bit smaller now because it's a wider or kind of a flatter point on the tool. All right, and then right here for the, and then right here we can tell it, let's go ahead and peck that one, and we'll do 1/2 inch pecks per peck. We're going to go 1/2 inch. And then finally the rapid's going to use the defaults. So I'm going to hit compute, and there's our drill. That one's always pretty quick. So now I'll just do a file save. And finally, the last one here should be the cutoff. So cutoff's going to work fine. We're just going to right click. Cutoff is pretty straightforward. It's the same thing as a drill. What you're picking is the point you want to use, the point you want to cut off to. So this is defining what point back in Z we're cutting off at, and what depth we're going in X to do the cutoff. And you can actually change it. So next, right here for the feature, we got our rapid plane. It's an OD cut because it's a cutoff. We could go from the stock, and that's it. So next. Well, I will say, if your stock was bigger, all right, so say I had a 6.5 inch piece of stock, and I turned this all down to 6 inches. By going from stock, we're recognizing it at the 6.5. So if you ever go to use, it's on this parameters page here. If you ever go to use a corner break on this, you might need to come in and set your custom size stock. All right, that's from the center line to where you want to go. So for me, it'd be 3 inches. So it's from here 3 inches up to the outside of our part. But because we use stock that fits our part, we didn't make any bigger stock, we don't have to really mess with that at all. So just going to go next. For the strategy, we have our cutoff, posting, separate moves or can cycles, depends on the post. For the cutoff tool, we have our 3.25 cutoff tool. It looks like it didn't make up a tool for me this time, which is good news. It's right there. It's the only one we got. Next, again, we have our parameters. So our Z cutoff is at -7.5. So that should be right there. And then we're cutting it off to 0.49. So it's actually going down 10 thousandths or thousandths lower than this. Doesn't really matter. But if we wanted to go a little further than that, that's the distance from the center line here up. So if I say let's go 0.25, it's going to be from this center line up 1/4 inch. So we will make sure to cut all the way through that. And then your retract amount is, what do you retract to? So I leave it at 0 for this one. We have a sharp corner on the part right there, but I'm going to go ahead and put a little chamfer on here. Just a 100 thousandths chamfer should be fine. And so that is just going to give us a nice little chamfer on the back of the part. Usually you'd want this drawn, but having it drawn doesn't change this toolpath at all. Because remember, we just picked a point. So I can add this in or I can turn it off. It doesn't really matter. And then you can choose whether you're going to peck this out or just plunge straight in. And I'm going to go ahead and peck this. We'll do our 100 thousandths, and our clearance will just be 20. So as it pecks, it'll go 100, clear 20. Go 100, clear 20. All right. And again, for the rapids, just going to use the defaults. So when we're all done, we can hit compute. And I'll do a save. And you'll see there is our cutoff right there. So that's our little chamfer move right there. And then that's our actual cutoff there. So it's going to come in. I believe it should do a half a cutoff, like it cuts off a little bit, comes back, moves over, does the chamfer, and then goes all the way down. If you ever want to see that, you could run the simulation, but you could also backplot by right-clicking, not on the feature. You won't see backplot in this menu, but you go to the specific operation. So you'd only be able to see one of these at a time. I can backplot the rough or the finish. Or in our case, we could backplot the cutoff. So you just right-click on it and say backplot. And you'll see here it comes. It's going to go in. It's going to make its cut, retract a little bit, cut our chamfer, and then it's going to cut its way down. That's our pecking moves that we got going on. So there we have it. All right, so looking at our cheat sheet over here, we have gone through, we just finished step 4 and 5. Step 4 was go make all your tool paths. Step 5 is repeat that and make as many tool paths as you need. The next one down is the machining order. All right, so we're going to make sure to check the machining order. Now, the machining order is found by right-clicking on the turning job. So kind of really the top level of the job, not CAM defaults, it's not in there, but right below that, you got your machining order. And if you're ever looking for something, like you can't find the machining order, start at the top and right-click. It's not in there, okay, right-click on that one. Oh, it's in there. But all these options are just, you can go in and make any changes by right-clicking on these things, all right? So I'm going to right-click and go down to my machining order. Now, the way I should have this right now, let me look at this. We got our lathe end face, and then we go to rough it, and then we do our lathe end face finish, and then we go to finish the turn. So the way it's sorted right now is by using this option. It's either one of these. I only have one machine set up with turning. So it's either one of these. It's individual tool, meaning it's going to try and keep tool 1 running as long as it can. Then it's going to switch to tool 2 and run it as long as it can. I want to do it not in the order that they set it up, but in the order I put the CAM tree. So I will have more tool changes happening, but I want to make sure that my roughing pass doesn't come into some material that hasn't been finished yet, or that I thought was finished and wasn't finished, stuff like that. So I'll go with an individual feature here, and it'll ask, are you sure? You say, yep. And so now we're going to do our rough, then our finish for the face, then our rough and finish for the turn, and then it's business as usual. We groove it, we center drill and drill it, and we do the cutoff. And the reason that didn't change is because we're not sharing any tools, and it's not going to put the finish before the groove rough, so it all works out. So we'll just hit OK. And then I'm just going to go ahead and blank out that tool path, and that's it right there. Let's go ahead and say File Save. So that was step number 6. Whoops. So step number 7 is verify your tool assignment. So I mentioned this earlier. I don't mess with the tool numbering until the end of the job. And so I right click here on turning tools, and I'm going to go down to verify tool assignment. Now, the first thing I want to look at in here is, are all the tools I planned on using, are they the ones that are in here? I usually get that all worked out while I'm doing my features, so it's usually not a problem. But you definitely have to pay attention to this because we saw it a few minutes ago. It made up some of these tools. What happens sometimes is the tool can be a different tool, even if the only difference between them is it's a little longer, which it makes sense. They're different things. They're not the same length, all that stuff. But when we're doing this, our tool, we just want to make sure we have the one tool. The tool we want to use is really all I'm trying to say here. You want to find the tool that you planned on using. So there's my CNMG, there's my VNMG. I got my 1/8 inch grooving tool, my 3/4 inch spot drill, my 1 inch drill, and my 3.25 length cutoff tool. So it looks good. I got no complaints. Everything matched up fine. But had I not caught those mistakes that were happening with the tools earlier, I could potentially end up with 2 different tools here. Maybe I got the right tool for the rough on the groove, but I got the wrong tool on the finish. So I'd have an extra grooving tool in here. So you always want to look at that, because if you're looking at just the simulation, you might not catch that there's another tool afterwards. So just be careful with it. The other thing about this, though, is tool numbering. Like I said, I don't do any tool numbering while I'm going through my features. I don't even worry about it. I wait till the end, and I come in here and I say use automatic tool numbering. I just uncheck that button. And so if I go ahead and hit OK now, if I edit my feature and I look at my tooling page, it automatically updated those retroactively. It's not something I have to come back and check. If I make that change, it'll fix it for me. But you could also change the tool numbers just by double clicking on them. So you could say this first tool is actually going to be sitting in slot, I don't know, 2. Maybe you have a certain tool in slot 1 all the time. Might be one of those situations. But the use automatic tool numbering is going to order the tools in the exact, it's going to number the tools in the exact order they're used. So first is first, last is last. So 6th tool is number 6 because it's the last tool used. But again, you can uncheck this and make any changes to the tool number. So hit OK. All right, we're on to the good stuff. Now, the next step is simulate the final program. If you find any problems, go back to step 4.2. So go back and start editing the parameters in the CAM wizard. I'm not anticipating any problems with this one. I'm thinking we're doing a pretty good job. So we'll say save first. Always, always, always save before you launch that simulation. Everyone's going to get burned at some point. You're gonna lose something, but always save before you load the simulation. It's like one of the hardest hits on the system, and the way my computer is acting all the past couple days, we're going to go for it. So I'm going to say launch simulation. I got my fingers crossed. All right. So simulation launches. You can view it however you want. I'm going to do one quick change here. I'm going to go here. What is this under options? I believe it's graphics and background. I want to turn off the machine center point there. I don't need that. There we go. All right, good. So the way I usually watch my my turning parts is I go to the views here and I go to a front view, which is basically how I've been staring at this part this whole time. So it makes my life a little easier. If you have any cuts that are being done on the ID, another thing you can do is right here for the, hold on, let me move this properties window over a bit. Move this guy over just a little, not much. That's good. It didn't open it enough. Come on, you can do it. There we go. So on this visibility tab, I have my stock, and currently it's set to show. But if I'm doing any cuts down the center of the part, what we can do is turn it transparent. And you'll still see the OD cuts happening, so I don't want to run too fast with this. You'll still see all those OD cuts running. Like that, but you'll actually see the drill cutting through the inside. So this is one of my favorite ways to look at it. You could also just turn it to show. That way it gives it kind of that deeper color. But yeah, there we have it. My rendering, current op segment, good. And you'll see as I'm cutting with these settings, the way I got them, this current op here under the toolpath rendering and this segment, those two settings right there, as I cut, you'll see the toolpath disappear. It's just showing me a segment of the toolpath at a time, and it kind of clears it away in between each one. There's my zoom. Okay, good. Got it. So there's our initial rough pass. There is our finish pass. I'd probably switch that to the CNMG. And then there's our groove. We probably would want to be pecking this one out. So that's another change I might need to make. But you'll see it left the radius, the material in there for the finish to put that radius on for us. And yeah, we're just going to go in and cut the second groove here. Right there. And then the finish comes in. Nice clean cut. Finish comes in. Again, you could do those grooves with a different type of finish pass as well. Then we do our center drill and drill. That's where I'm going to turn this part transparent. And we can see it cut. Now, if we see any red show up in here, it's because that portion that's beyond the copper, that's our flutes right there. So we might start getting some red, possibly. I don't know. It should be the same size shank, so it might not be too upset about it. There it is. And then we're going to go in. We've put our chamfer on the back of the cutoff there. We ran really fast. Let me stop this. Restart this, and I'm just going to fast forward right to the cutoff here so we can see it again. So it's going to go in, it's going to plunge in a little, make our chamfer, and then it's just going to cut right down there. And we have that peck amount in there. So it's just going to peck its way through right there. Parts free. And then one last thing you could do, and it's up to you if you do this, but if you want to see what the back of this thing looks like, over here under this measure tab, all right, so there's let me move this over a little bit. There's this measure tab right here on the bottom set of toolbars. What do we call it? Yeah, toolbars, docking panes. And there's a bunch of options in it. You can use it to take measurements, which I wouldn't recommend. It's not super accurate or anything. But right here, you have this remove chips option. And so I'm going to go right here and say remove chips, only keep one part. And so what this allows me to do is you're going to use your middle mouse wheel like it's a button, and you're going to click on the part that you want to keep. So I click on that right there, and it removes anything else. Here's the thing. Make sure to turn this off when you're done. Because the simulation, to rotate in the simulation, it's a left click, hold, and move your cursor, drag your cursor. If we're inside RHINO and we're in like the perspective view, you rotate using your middle mouse wheel. So a lot of times, and I've done this before, and I've had many customers do it, you'll come in here to go rotate, and you'll click that middle mouse wheel down to rotate, and it'll delete the part off the screen. So just make sure to turn this guy off again so that doesn't happen. But now you can see there it is. We got our hole down the center. You know, overall, go to a front view or a top view. It doesn't really matter. It's all the same part at this point. But there it is. Looks good. So we're just going to close out of the simulation. I have no complaints with that. Everything looked pretty clean. And so now step number 9 is we post the code. So, whoops, get out of there. So posting the code, the first thing you do, again, I said this at the beginning, the BC2X lathe is a fine machine to use. There's no, you don't have to worry about the machine that's being used. The important bit is when you expand this here, you have the correct post processor. So I have this single line post. If I go in here, well, let me do that again. I don't want to skip a step. You right click on it and say edit. You can go right here to select for the post processor. There is a bunch of them in here already. Right here, we got a bunch of Mesa trolls and stuff like that, Analams. But if you don't see something that works for yours, these are all the posts that we would call OEM posts. They work for most of these machines. So if you have a Haas lathe, the Haas lathe or the Haas 2X lathe will probably run your machine. But if you don't see your post right here, we're going to look. I'm going to show you guys the website here in a couple minutes and show you where you can find these. So I'm going to use the single line, or I'll use the single line for now. And so after you verify that you have the right post processor, you're going to right click on turning job, and you're going to go ahead and say post. And all the code is going to show up here on this posting tab. Now from here, you can right click and either just save the code, or you can launch the NC editor. Now the NC editor, let's see if it loads even. There we go. All right, we're getting it. It's working. Now the NC editor is essentially just a text editor, but it also has what's called syntax highlighting built into it, which is nice. So all your G commands will be a certain color highlighted. Your N's are a certain color. Your Z's are a certain color. All that stuff, everything comes down with a specific color, so it's easier to see and easier to kind of spot. If you do make any changes through here, you can just go to File, Save As, or Save, yep, and then Save As. Just make sure when you save it, you're saving it as the correct file extension. All right. The NC editor is separate than BobCAD's file extension. So you right click in here, you say save as, you'd save the code to a flash drive or onto your network, and however you get it out to the machine. It's right after you hit save as, it's business as usual. However you get that part out to the machine or that code out to the machine, that's what you're going to do. All right. All right, and then finally, the last little step that they have in here is generate a setup sheet. So you generate setup sheets by going to your CAM tree. You right-click on your turning job, and right down here we have generate setup sheet. I don't think there's a shortcut for that anywhere. No, there's not. Yeah, there's nothing in there. The way I usually do this in the standalone version of BobCAD, we have a button that's up at the top on the toolbar. I don't think I can add to this toolbar. I'm almost positive. Yeah, I can. So what I like to do is when you do this setup sheet, we actually do a screenshot of the part. So the way I usually run this is I turn my stock on, and then I try to get it to show this, but as soon as I click off the turning, as soon as I click off the machine setup, it'll disappear on me. But we'll generate our setup sheet. Let me get this centered on here nicely, because we're going to actually take a screenshot of this. So we're going to generate our setup sheet. Now there's like a bunch of setup sheets, but you'll notice a lot of them are for mill or wire. The only one we want to use is the full setup sheet. So you're just going to pick that and hit OK. And you're just going to wait. This is going to load inside of Internet Explorer, or I believe, let's just double check, inside the settings now, you can set up a browser. So you can actually say use the default browser or go and pick the browser. The reason is on Windows 11, they finally got rid of Internet Explorer, and so you need to be able to pick a browser for it. So just so you know, I don't need that. And so it loads up here in Internet Explorer. We make that big. And you'll see it's got the name of the file there, the post processor, the machine, the date and time, the total, your program number, your units, total cutting distance, total rapid distance, number of operations, number of tools, number of setups, and the total cycle time. Now, cycle time is all calculated based on the feeds and speeds that we set up, and we didn't really set up many feeds and speeds. So you definitely want to go through and make sure to get your feeds and speeds right, and then that will be a pretty accurate number. Got our material listed there. We got our length, width, height of the stock. We have our tools, all right? So we have a breakdown of what the tool is on each one. We got the name of it and everything. Basically, if you were the one just programming this and you weren't going to be the one machining it, with this setup sheet, it really does tell you just about everything you need to know about how we cut the part. Down below all the tools, you actually see what order we do all of our operations in. So you got to see everything. So our initial rough at these feeds and speeds is 1 minute, 27 seconds. The way that we do this calculation is we have this feed rate and we have our feed distance. So we just divide them up and that's how we know it works. So you got your finish. You look at that, 17 minutes on that rough. But yeah, right there. All of our tools, the cutoff, everything. Now to save this, there's no save on here that I know of. I guess there is a save as. I've never used that. So you right click in here and just say print. And then what I use, because I'm on Windows 10 here on this PC, but I believe Windows, I know Windows 8 had it. I don't know about Windows 11, but I don't think they took it away. You have your Microsoft Print to PDF. So you pick that, you say print, you wait a second, and then right there it pops up. Let me find my folder for this. RHINO, lathe examples. There we go. And so I'd give it a name. So this is Lathe Tutorial 1. And then I could just say save. So now if I ever need this again, after I close it out, all I have to do is open up that folder. Where'd it go? There it is. Open up that folder, go down to my examples, and right here, the PDF, I could open it up. And there it is. So I'd be able to print it out later on, do whatever I need to with it. All right, so close that, go over there. All right, so there is, that's kind of the last step to it. And we have a fully finished part. Got our code and everything. So that's it. I'm going to show you guys the website, the posting real quick, just in case you don't know about it. And then, yeah, that'll be pretty much it for the day. So this right here, I'm using Google Chrome. I don't recommend using I don't recommend using Internet Explorer or what is the new one, Edge, Microsoft Edge. I've had people talk about not being able to download posts and stuff. But the website we're going to go to is just BobCAD-support.com. And I've actually never logged into it with this Google Chrome here. So I'm not even going to sign in. First thing I want to show you is the training section, because that's my thing. So when you go to training, all these recorded events, so I know a couple of you guys showed up a little late. We didn't really do much. I actually started late because my computer decided to restart. But if we go down right here to the recorded virtual events schedule, You guys are actually able to watch all of these. Now, I know you're using this RHINO plugin, which is cool. But the big thing that if you guys can make the connection, I've had a couple guys do it now. The CAM is the same between all of our versions. So our version 34 standalone system, our SolidWorks system, and our RHINO system, they all use the exact same CAM. All the steps that you do, all the geometry that you pick, minor differences, like the RHINO or inside of SolidWorks when you do turning, you don't use wireframe, you use solids, you use the surfaces. But all the settings are the same. Everything is the same. So if you want to expand a little bit more on this and you can make that connection, all these videos are fair game for you guys. You can watch any single one of these. They got V9, V34. The only difference would be anything that's done as CAD, like V34 here. I'm not good with SolidWorks or RHINO. Truthfully, I'm just not that good at them. But version 34, I'm fantastic. I could draw things in there. I could do a lot of stuff in there. So if something happens, or if you want to look at them a little bit more, we do a lot of these events that if you can make that connection, you're gonna have a good time. Like here's a RHINO mill one we did. But these are all free. You don't even have to sign in. You don't even need a login for this stuff. You just come in here and you'll be able to watch them. We got Bob Art, Laser Plasma, Water Jet. I guess this is the first RHINO. That's a milling one that Andrew did. This must be the first RHINO lathe, I believe. V33. Cool. So this is the first one. Oh yeah, I believe it got canceled the last time we did it. So any of these videos, they're fair game to watch. Again, if you go into one of these V9 videos or V34 videos because you want to see this 3D CAD and CAM or whatever, you can just go in there and watch it. And all the way you pick geometry is pretty much the same. The way you set up the tool paths are all the same. The wizards actually all look exactly the same as you next your way through. So if you could at least get to the point, in RHINO here where you got the stock made and you're just ready to start tool pathing, all this tool pathing is the same. When you get into these wizards, this is literally the exact same wizard between all three versions. So it's up to you if you want to go that route. I do plan on going into more RHINO stuff in the future. It's our newest product. We've only had it out for 2 versions now. And so we're still waiting for more people to pick it up and start using it. And and just that's my next big thing is more RHINO and SolidWorks stuff. So all right. So back to that page. So the other thing on this page, again, no sign in needed, but you go to your post processors and then say, I want to download a post. And from here, if we scroll down, your customer ID is required. And then right here, you can pick your versions. So you got RHINO V1, V2. It's whatever you're using. Right here, we're going to go with lathe. And then right here's all the different lathe controllers that we have. So you go, let's say something like what's going to have a good amount of Fanuc. And you'll see here's all the Fanuc posts that we have. So yeah, you're just going to have to look at it, pick a post and it'll show you a little sample there. You kind of want to look to what matches the type of code you're used to. But yeah, that's pretty much it. Then you hit download. Now, if the post you download or the post you're using inside the software isn't right, then you can request a change to the post processor. So requesting a post processor modification or requesting a completely new one. Requesting a completely new one is usually, I don't know, most people just need to do a modification. But it's up to you. If you can't find your machine in post at all, then yeah, we'll make you a fresh one. If you decide you need to make a new post or you want to request a modification, there's a couple things we need. Now, modification-wise, it's going to be really a sample program. It all depends on what needs to be modified. But a lot of times, the way we do these posts is if you send us a sample code that runs on the machine, we're going to make a post that pretty much matches it. As far as CAN cycles go, you need to provide the examples of the CAN cycles for us to be able to match up to those. So There's a little bit to it, but shouldn't be too bad. So there it is. That's the this is the support site, and if you do sign in, then you'll actually have you'll actually be able to go in and see all of your account information. I've never signed in with this site, so I don't have my password saved or anything. Oh wait, maybe I do. Nah, that's the old one. I knew it. All right, so that's it right there. Any questions? All right. Well, I'll give you guys a second if you got any questions. I'm going to stop the recording now.